Here is something that should genuinely unsettle you. Right now, your blood is moving, your electrons are moving, the atoms in the chair beneath you are vibrating, the tectonic plate under your city is sliding, the galaxy you live in is spinning at 230 kilometers per second. At every scale, from the quantum to the cosmic, is in motion, not approximately, not mostly. And physics has a law for this, a law so deep it is practically a definition of what reality is. Nothing at absolute rest, nothing ever completely still. Even at the coldest temperature the universe permits, matter still moves. Quantum mechanics forbids alternative with the same severity it forbids anything. So the question is not academic. What would happen if everything stopped? Not slowed down, not cold to near -0. Stopped, completely, simultaneously. Every particle, every wave, every photon mid-flight, every electron mid-orbit, all of it, zero. The answer is not explosion. It is not silence. It is something far stranger, and the road to it passes through every major branch of physics, breaks most of what you think you know about time, and ends at a question that the laws of nature themselves cannot currently answer. If you are new, welcome to Sundown Science. Subscribe and get comfortable. We are about to follow stillness from the surface of your skin down to the fabric of spacetime itself, and discover that the universe has a name for what you are imagining, and it is not possible. But the reason it is not possible is the most important thing physics has ever told us about what motion actually is. Part 1. The illusion of stillness. You have probably had the experience of sitting perfectly still, maybe reading, maybe waiting, maybe just existing in a quiet moment. It feels, genuinely feels, as though you are not moving at all. That feeling is one of the most comprehensively wrong sensory experiences available to a human being. At the surface level, the level of planets and orbits, you are being carried eastward at roughly 1,670 kilometers per hour. That is faster than the speed of sound. You feel none of it. The Earth is simultaneously orbiting the Sun at 30 kilometers per second. The Sun is moving through the Milky Way. The Milky Way is falling toward the Virgo supercluster at something approaching 600 kilometers per second. Every frame of reference you have ever used is an anchor for the word still is itself moving. But those are the large-scale motions, the ones that seem abstract because they are too slow or too vast for your body to register. Drop down to the scale of molecules and the story becomes visceral. The air in the room around you is not still. Each nitrogen molecule in that air is moving at roughly 500 meters per second, changing direction about 10 billion collisions with other molecules. What you experience as atmospheric pressure is not a static push. It is the statistical result of roughly 10 to the 23rd molecules per cubic meter, hammering every surface they encounter billions of times per second. The table you might be resting your hand on is not still. Its atoms are vibrating in place, oscillating at frequencies determined by the temperature. At room temperature, around 300 Kelvin. Those atomic vibrations carry energy of roughly 25 millielectronvolts. They cannot stop unless the temperature reaches absolute zero. As we will discuss in detail, they do not fully stop. Quantum mechanics prevents it. Drop further, to the scale of atoms. The electrons are on every nucleus in your body, are not sitting in fixed orbits the way a planet circles a star. They exist as probability clouds, smeared distributions of possible positions and momenta, never localized, never stopped, never at a defined position and a defined velocity simultaneously. That impossibility has a name. It is the uncertainty principle, and it is not a limitation of our instruments. It is a fundamental feature of what quantum objects are. The stillness you feel when you sit quietly in a room is a macro-scale averaging of motion. At every scale below the one your senses can detect, you are an enormously complex aggregate of things in motion, arranged so carefully that the net effect at the scale of your body feels like rest. That rest is an illusion, a very useful, very stable illusion, but an illusion. So, when we ask what would happen if everything stopped, we are asking what would happen if that illusion became real, if every layer of motion, from the orbital to the molecular to the quantum, simultaneously and completely ceased. And the first answer physics gives you is brutal and immediate. It cannot happen, not because of engineering limitations, not because we lack the technology to stop things, but because the laws of physics as currently written make total stillness not just difficult but definitionally impossible. Part 2. The floor that quantum mechanics put under motion. In 1927, Werner Heisenberg published a result that permanently changed what the word position means in physics. The uncertainty principle states that there is a fundamental limit to how precisely you can simultaneously know the position and the momentum of any quantum particle, not a practical limit, not a limit set by technology, a hard mathematical limit baked into the structure of reality. The more precisely you know where something is, the less precisely you can know how fast it is moving, the more precisely you know its momentum. The more smeared out its position becomes, the product of the two uncertainties can never be smaller than a specific constant, the reduced Planck constant divided by 2. The implications for our thought experiment are immediate and fatal. Stopping everything means giving every particle a zero momentum means perfectly defined momentum. Perfectly defined momentum means completely undefined position. A particle with exactly zero momentum would be smeared uniformly across the entire universe. It would have no location at all. It would not be somewhere in particular. It would be everywhere equally. This is not a metaphor. This is what the mathematics of quantum mechanics literally predicts. For a particle with exactly zero momentum, particle in a specific location is internally contradictory in quantum mechanics. The stopped particle would have to be nowhere and everywhere simultaneously, which is not stillness, it is dissolution. There is a related consequence called zero-point energy, even at absolute zero temperature. The lowest energy state physically achievable, quantum systems retain a residual energy. They vibrate, not because they have thermal energy to express, but because quantum mechanics prohibits the alternative. A harmonic oscillator at absolute zero, a quantum spring at its lowest possible energy state, still vibrates with an energy of 1/2 times the Planck constant times its frequency. That energy cannot be removed. It is not a property of the temperature. It is a property of what it means to be a confined to a finite region of space. Confine something and it will move, not because it wants to, because the alternative violates the uncertainty principle. Motion is not something quantum systems do. It is something quantum systems are. The universe has put a floor under motion. And that floor is not set by temperature or pressure or any condition you could engineer away. It is set by the structure of reality. Let us hold the quantum objection in reserve for a moment and ask a different question. What if we ignore quantum mechanics for the thought experiment? What if we step into a classical universe where particles are points with definite positions and momenta, and we stop them all? What happens then? The answer gets stranger the more carefully you think about it, and it starts with heat. Part 3. Temperature is motion. So what is cold? Temperature is not a thing, it is a behavior. Specifically, it is a statistical description of how fast the molecules in a substance are moving. Hot means moving fast, cold means moving slow. Absolute zero, which is negative 273.15 degrees Celsius, or 0 on the Kelvin scale, is the point at which that molecular motion reaches its minimum, not where it stops completely, as we have seen, but where it is as slow as the laws of physics permit. So if you stop all motion, you do not just cool everything down. You set the temperature of everything to a value below absolute zero, which is not a lower temperature. It is a category that does not exist in classical thermodynamics. Temperature below absolute zero is not colder than absolute zero. -5 is colder than 0. It is a physically undefined state. Temperature requires motion to exist as a concept. In a universe where nothing moves, the word temperature has no reference. It is like asking what color sound is. The question is not hard to answer. It is not a question. But here is what that means for matter. Every phase of matter, solid, liquid, gas, plasma, is a description of how matter behaves at a given temperature and pressure. Solids are rigid because their atoms vibrate in place but lack the energy to break their lattice positions. Liquids flow because their molecules have enough to slide past each other but not enough to escape each other entirely. Gases expand because their molecules have enough energy to travel freely between rare collisions. Stop all motion, and none of these descriptions apply. Matter does not become an ultra-cold solid. It becomes something that has never existed and has no name. Not because the state is exotic, but because the concept of state requires matter to be doing something. And you have just told it to stop. The atoms in your body stop at their positions, would be fixed. But fixed is not the same as stable. The forces between them, electromagnetic attraction and repulsion, would still exist, and those forces, acting on things with zero velocity, would immediately begin to accelerate them, not because the laws of motion resumed, but because, if the laws of physics are still operating, then force still causes acceleration, and the stop particles are not in equilibrium positions. They are wherever they were when you froze them, which for most of them is mid-vibration, mid-orbit, mid-collision. The moment you release the freeze, they do not continue gently, they lurch violently toward the nearest stable configuration, which for molecules means toward chemical bonds, and for matter at larger scales means toward whatever gravitation and electromagnetic equilibria the forces are pulling toward. But we have not even reached the most disruptive part of this scenario, because the most disruptive part is not what happens. It is what happens to light. Part 4. Stopping light is stopping time. Light is not matter. It is not made of atoms. It does not vibrate around a lattice position. It is electromagnetic radiation, an oscillating wave of electric and magnetic fields propagating through spacetime at that number is not approximate. It is exact. It is the definition of a meter, 8 meters per second. And it is not just the speed at which light happens to travel. It is the speed at which any massless particle must travel. There is no frame of reference in which light is at rest, not because we cannot build one, because special relativity proves that such a frame cannot exist. Light at rest is a category error, like a triangle with 4 sides. The words do not describe anything, but there is a deeper reason why stopping light is not just difficult but logically incoherent. Light is not moving through time the way you are. According to special relativity, objects moving close to the speed of light experience time dilation. Their clocks run slow, moving at 99% of the speed of light. It's about 7 times slower than a stationary clock. Extend this to the limit. A photon traveling at exactly the speed of light experiences 0 elapsed time between its emission and its absorption. If photons had perspectives, the entire journey happens instantaneously. A photon leaving a star 1,000 light-years away and arriving at your eye tonight has experienced 0 time in transit. For that photon, Emission and absorption are the same moment. Light does not travel through time. It exists outside it. Which means stopping light is not just stopping a particle. It is demanding that a thing which exists outside time enter time, and the universe has a very specific reaction to that demand. It does not comply. The universe of a room full of stopped photons is a universe where the electromagnetic field is static. No propagating waves, no changing field strengths. No force transmission, because the electromagnetic forces are transmitted by the exchange of virtual photons. No chemistry, because chemical bonds are electromagnetic. No light reaching your eyes, because the photons from every surface around you have stopped mid-flight. You would not see darkness. Darkness is what you see when no photons are arriving. In a stopped universe, the photons are frozen at fixed positions between their sources and your eyes. What you experience as vision is the continuous flow of photons from surfaces to your retina. Stop the photons, and the retina receives nothing. The last photons already absorbed are the last signal your visual cortex receives. And then nothing. Because the neurons that would register blackness also require electrochemical signals, which require ion movement, which requires motion, which has stopped. You would not even experience the absence of light. You would not experience anything at all. Because experience requires the motion of charge through neurons. And we have stopped everything. Part 5. What happens to you? The human body is not a solid object. It is a process, a dynamic, self-maintaining, continuously active chemical process that requires constant molecular motion to remain what it is. Your heart beats because the actin and myosin proteins in cardiac muscle cells slide past each other. Driven by the hydrolysis of ATP, which is the release of chemical energy stored in the phosphate bonds of adenosine. The process requires the movement of molecules. Your neurons fire because sodium and potassium ions rush in and out of cell membranes through protein channels. That requires the movement of ions. Your immune system works because white blood cells move through blood vessels, identifying and destroying pathogens. Motion. Your DNA replicates because polymerase enzymes travel along the double helix, reading the code and building complementary strands. Motion. Your cells produce energy because electrons flow through the mitochondrial electron transport chain, driving hydrogen ions across membranes to power ATP synthesis. Motion. Every function that makes you alive is motion. There is no version of a living organism that is also completely motionless. Life is not a property of matter at rest. Life is a pattern of organized motion. Stop the motion, and the pattern does not become a frozen version of itself. It ceases to be, not gradually, not after a process of dying, instantaneously and completely. There is no moment of stopped consciousness before non-existence. Consciousness is not something your brain has. It is something your brain does. And doing requires motion. The atoms of your body stop at their positions, would still be your atoms, in approximately your arrangement. But the you that is reading this sentence right now is not your atoms. It is their organization and their motion. Remove the motion and you remove the you. What remains is a sculpture. Not a frozen person, not a preserved person, a very precise arrangement of atoms that used to be a person. This distinction is not philosophical hair-splitting. It is the most precise description physics can offer of what identity and life actually are. Motion is not incidental to life, motion is life. Part 6. What gravity does to the stopped universe. Assume for the thought experiment that everything stops and the laws of physics are then allowed to resume. Operating on the newly stopped configurations, the first thing that happens is not dramatic at the atomic scale. It is dramatic at the astronomical scale, because right now, the planets are not held in orbit by a static balance. They are held in orbit by a precise dynamic balance between their forward velocity and the gravitational pull of the sun. Newton's first law says an object in motion stays in motion. An orbiting planet stays in orbit because it is falling toward the sun while simultaneously moving forward fast enough that it keeps missing the sun. That is what an orbit is. Perpetual falling, perpetually missing. Stop the forward motion, and there is no more missing. Stopped at its orbital position, with zero orbital velocity, would immediately begin falling directly toward the sun, not drifting, not slowly, accelerating. At the current distance of 150 million kilometers, the sun's gravitational acceleration of the Earth is approximately 6 millimeters per second squared, small at first, growing as the distance decreases. The Earth would reach the sun in approximately 64 days. Not arrive gently, collide at roughly 600 kilometers per second. The kinetic energy released in that impact would be comparable to billions of nuclear weapons detonating simultaneously. The Earth would not impact the sun's surface intact. The tidal forces as it approached would begin tearing it apart, long before contact, pulling the near side more strongly than the far side until the planet fragments into a stream of spiraling into the solar atmosphere. But that is just the Earth. Every planet in the solar system would do the same. Jupiter, 318 times Earth's mass, falling into the sun, Saturn, and its rings as they cross the Roche limit where tidal forces overpower self-gravity that holds them together. The solar system does not freeze in a stopped universe. It falls toward its center on a schedule determined entirely by how much orbital velocity it just lost. And what is true of the solar system is true at every Stars scale. Orbiting the galactic center would fall inward. Galaxies orbiting cluster centers would collapse. The large-scale structure of the universe, the web of filaments and voids that took hundreds of millions of years of gravitational dynamics to build, would be disrupted by the sudden removal of every velocity. Gravity does not stop when motion stops. Gravity is a property of mass and spacetime, not of motion. And in a universe where nothing is moving but mass still warps spacetime, the geometry of the universe has just been handed a set of initial conditions it was never meant to receive. And general relativity will evolve those initial conditions with complete indifference to what they mean for anyone or anything inside the universe. The result is collapse at every scale, simultaneously. Part 7. The Nuclear Question. The nucleus of an atom is held together by the strong nuclear force, the most powerful fundamental force in nature, operating over distances of roughly a femtometer, 1/4,000,000th of a meter. At that scale, the strong force is approximately 100 times more powerful than electromagnetism, which is the force trying to push protons apart. The nucleus holds together because the strong force wins. Barely in larger nuclei, but it wins. Now consider what stopping everything means. For nuclear stability, the protons and neutrons inside a nucleus are not sitting stationary inside a potential. They are moving rapidly. The nuclear wave function. Soft nucleons inside a nucleus have kinetic energy of order tens of MeV, millions of electron volts. That kinetic energy is part of the balance that keeps the nucleus in its ground state configuration. Strip out the kinetic energy by stopping the nucleons, and you have changed the energy balance inside every nucleus in the universe simultaneously. For stable nuclei, this may simply mean they relaxed a new configuration. For unstable nuclei, the loss of kinetic energy could trigger decay modest that would not otherwise have been accessible. The details depend on specifics we cannot fully calculate for this thought experiment. But the direction of the effect is clear. Stopping subatomic motion destabilizes nuclear structure. Destabilizing nuclear structure releases nuclear energy. The same energy that makes nuclear weapons work. Not from one nucleus, from every nucleus. In every atom, in every object, on every planet, in every star, simultaneously. The energy budget of that event is not comparable to any explosion or any event in the history of the universe. It is the total nuclear binding energy of all matter everywhere, released at once. The universe would not survive this as a universe. It would be transformed into a different thermodynamic state in a time scale determined by how fast the nuclear reaction could propagate through matter at the speed of light, which is to say, in a timescale comparable to the light crossing time of whatever structures we are considering. This is not an explosion in space. It is space being redefined. Part 8. What time does when motion stops? Here is the deepest version of the problem, and it requires a careful look at what time actually is. In Newtonian physics, time is an absolute backdrop. It flows uniformly everywhere, providing a universal against which all motion is measured. In this picture, stopping all motion leaves time continuing. Things are still in a still universe, but the clock ticks. Einstein changed this picture completely. In special relativity, time is not absolute. It is a dimension woven into spacetime, and its rate of passage depends on velocity and gravity. The faster you move, the slower your clock runs. The stronger the gravitational field, the slower your clock runs. GPS satellites have to correct for both effects, or they would accumulate errors of kilometers per day. Time dilation is not theoretical, it is measured constantly. But there is a more radical implication in general relativity, one that has been sitting quietly in the mathematics since the geometry of spacetime, the shape of the four-dimensional manifold in which all events occur, is determined by the distribution of mass and energy. The presence of mass curves spacetime, and that curvature is what we experience as gravity. But the geometry also determines the causal structure. Which events can influence which other events, where the future is relative to the present. In a universe where everything is stopped, the question of what time does next becomes not just unanswerable but possibly meaningless. Time and general relativity is not a backdrop. It is a relationship between events. If there are no events, if nothing is changing anywhere, if every process has halted and every particle is static, then what does it mean to say that time is passing? Passing relative to what? Relative to which change? The philosopher Gottfried Leibniz argued in the 17th century that time does not exist independently of events. It is the ordering of events. It is what we call the sequence of before and after. Remove all events, and you do not get time continuing with nothing in it. You get the concept of time becoming undefined. Modern physics is not as keen on this point as Leibniz was. General relativity does not require material content to define time. The vacuum solutions of Einstein's equations have well-defined time coordinates even in empty spacetime, but those solutions are still dynamic. Gravitational waves can propagate through empty spacetime. Spacetime itself can expand or contract. The motion you have stopped is the motion of matter, but spacetime itself has dynamics. And if the mass distribution has stopped, the curvature is fixed, and the spacetime geometry stops evolving in the way general relativity usually describes. You have not stopped time. You have removed the reason for time to have any consequences, which is, depending on how you define time, the same thing. Part 9. The Thermodynamic Impossibility. There is a law of physics called the second law of thermodynamics, and it is, in the opinion of many physicists, Not the most elegant law we have, not the most precise, the most important. It states that the entropy of an isolated system either increases or stays the same. It never decreases. Entropy is a measure of disorder. More precisely, it is a measure of the number of microscopic arrangements of a system that correspond to its macroscopic state. A glass of hot water has higher entropy than a glass of ice because there are more ways to arrange the water molecules to produce the macroscopic property of being hot. Then there are ways to arrange them to be an ice cube. The second law says you can go from ice to water. You cannot spontaneously go from water to ice in an isolated room, not because something prevents it physically, but because the probability is so astronomically small that it has never happened in the history of the observable universe, and never will. The second law is a statement about probability so overwhelming it functions like certainty. Now here's the problem for our scenario. A universe where everything is stopped is a universe in the lowest possible entropy state, not low entropy, the lowest conceivable entropy. Every particle at a defined position, no thermal motion. No uncertainty in state, no disorder whatsoever. The second law of thermodynamics says systems evolve from low entropy toward high entropy. A universe instantaneously placed in its minimum entropy state would have the maximum possible thermodynamic pushing it toward disorder. Every law of statistical mechanics would be pointing, screaming, in the direction of more motion, more disorder, more entropy. The universe would resume, violently, immediately. And here is the beautiful, terrible irony of that. The state you stopped everything to achieve is the state from which the universe expands most explosively. A universe at minimum entropy is not a frozen universe. It is a universe one instant before maximum expansion. It is in structure if not in origin similar to the state the universe was in immediately after the Big Bang, not the same, but analogously extreme. Low entropy, highly ordered and stable, pointed at the future like a compressed spring. The Big Bang was not an explosion into space. It was an explosion of space from a state of extraordinary low entropy. If you somehow set the universe back to minimum, entropy be stopping everything. You have not ended the universe's story, you have reset it to its first page. Part 10. The Quantum Revival. Quantum mechanics has one more contribution to this scenario, and it is possibly the strangest one. Quantum systems are described by wave functions, mathematical objects that encode the probability of finding a particle in any particular state when you measure it. Wave functions evolve over time according to the Schrödinger equation. That evolution is deterministic and reversible, given a wave function at one time. You can calculate what it was at any earlier time and what it will be at any later time. The Schrödinger equation knows no error of time. It runs forward and backward with equal validity. Now consider a quantum system in a superposition of states. An electron in a superposition of spin up and spin down. A particle in a superposition of being into location simultaneously. The wave function of such a system is spread across possibilities. Stopping the electron would mean collapsing it to a definite position and momentum simultaneously. But measurement, the act of establishing a definite state, requires interaction, which requires motion. You cannot collapse a wave function without interacting with it. You cannot interact without exchanging particles or forces. You cannot exchange particles or forces without motion. Stopping everything includes stopping all quantum measurements, all quantum decoherence, all wave function evolution. The universe would not have definite classical states. It would be a static superposition of every quantum state it had been in, which is not a frozen classical picture. It is an incoherent quantum fog. Not a stop movie, a pile of film frames, all occupying the same moment with no projector running and no order to separate one from another. And here is the part that comes back around. Quantum systems in finite volumes exhibit what are called quantum revivals. An evolving quantum wave function will, after a sufficiently long time, return to a state arbitrarily close to not its initial state. Something pushes it back, because the mathematics of unitary quantum evolution in a finite Hilbert space guarantees it. The system cycles, not forever in exactly the same way, but through all of its accessible states over a sufficiently long time. The Poincare recurrence theorem says something similar. For classical systems of finite phase space, given enough time, any classical system will return arbitrarily close to any previous state. A universe stopped and released would, in principle, eventually revisit its stopped state again. Not soon, on timescales that make the current age of the universe look like a single Planck time, but in principle, in a universe that permits quantum and classical recurrence, the stopped state would return, and motion would stop again, and then resume again, and stop, and resume, on timescales so vast they are not numbers anymore. They are poems about numbers. Part 11. What the question reveals about motion. We have arrived somewhere unexpected. We started asking what would happen if everything stopped. We expected an answer about explosions or cold or darkness. And we found those things. But the deeper finding is not about the consequences. It is about what the attempt to stop everything reveals, about what motion actually is. Motion is not something matter does. Motion is not a property some things have and others lack. Motion at the quantum level is an intrinsic feature of what matter is. The uncertainty principle does not say particles move, but we cannot track them. It says the concept of a stopped, located particle is not a description of anything real. Particles are not tiny balls that happen to be moving. They are quantum objects for which position and momentum are complementary, irreducibly uncertain, and never simultaneously defined. Their motion is not a behavior. Temperature is part of their property of matter heated by something. It is a description of how matter behaves. When it is aggregated into large numbers of particles, remove the motion, and you do not produce cold matter. You produce something that has no temperature at all. Which is not a thermodynamic state. It is the absence of thermodynamics. Time is not a clock ticking in the background waiting for events to happen against it. Time is the ordering of change. Remove change, and you do not produce empty time. You produce the absence of the thing. Time is a description of, and life is not a property of certain arrangements of matter. At rest, life is the motion, it is the process. Stop the process, and there is no organism remaining to be dead. There is just matter, in an arrangement, that used to sustain a process. Every consequence we explored in this thought experiment followed from the same root insight. Motion is not optional. Motion is not contingent. Motion is constitutive. It is part of what it means to be matter in a quantum universe subject to thermodynamic laws. Part 12. The open question at the bottom. But there is a version of the stopped universe question that physics cannot dismiss as easily. It is not the version where you stop all molecular motion, or all quantum motion, or all photons. It is the version where you ask what happened before motion began, not the motion of planets or atoms. The motion of spacetime itself, the expansion. The universe is expanding. Right now, every galaxy beyond our local group is receding from us. The further away it is, the faster it is receding. The expansion is not galaxies moving through space. It is space itself expanding. The distance between things growing because the fabric of spacetime is stretching. That expansion began approximately 13.8 billion years ago. In the event we call the Big Bang. Before the Big Bang, if before is even a meaningful word here. The question of what was happening is genuinely open. General relativity predicts a singularity at the Big Bang, a point of infinite density and temperature. But singularities in general relativity are usually signals that the theory is being pushed beyond its range of validity. The singularity is not a description of what happened. It is a mathematical flag marking where we need a better theory. That better theory, quantum gravity, would have to tell us what happened at and before the Planck time, the first 10 to the minus 43 seconds of the universe's existence. We do not have that theory. What we have are proposals. The Hartle-Hawking no-boundary proposal suggests the universe did not have a beginning in time. In the usual sense, that time itself emerged from a quantum geometry that was not characterized by a distinct first moment. In this picture, asking what happened before the universe is like asking what is south of the South Pole. Not unanswerable because we lacked information, unanswerable because there is no south beyond the South Pole. There is no before the universe. The question dissolves in the geometry. Loop quantum cosmology suggests the Big Bang was not a beginning but a bounce. A previous contracting universe reaching a maximum density determined by quantum geometry rebounding and beginning to expand again as our universe. In this picture, there was a before. A universe collapsing toward minimum size, where minimum is set not by a singularity but by the Planck scale. That collapsing universe was full of motion, the motion of contraction, the motion of matter, the motion of quantum fields at scales that general relativity can't describe but quantum gravity might. In neither of these proposals is there a moment before motion. In the Hartle-Hawking picture, the universe emerges where from motion as we understand it has no clear meaning, but neither does motionlessness. In the bouncing cosmology, there has always been motion, the idea of a universe at rest. A true initial stillness preceding the explosion of everything is not supported by any serious proposal in quantum cosmology. Motion does not appear to have had a beginning any more than time did. They appear to have arrived together, or to have emerged together, or to be the same thing described from two different angles. Part 13, Final Synthesis. Let us take stock of what we found. We asked what would happen if everything stopped. And we found the following. Quantum mechanics prohibits total stillness. The uncertainty principle makes a particle with exactly zero momentum a particle smeared across infinite space. 0-point energy ensures that even at absolute zero, matter retains irreducible quantum motion. Stopping everything does not produce cold. It produces a state outside thermodynamics entirely. Temperature, pressure, phase, entropy, all concepts that require motion, remove motion, and these words lose their reference. Light cannot be stopped without violating special relativity. Photons have no rest frame. Stopping light would mean stopping force transmission, chemistry, sight, and every process that moves information from one place to another. Would fall into the sun in 64 days. Every orbit is a dynamic balance. Strip the velocity, and gravity completes the unfinished infall. That orbital motion was perpetually deferring. Nuclear structure would be destabilized. The kinetic energy of nucleons inside nuclei is part of what holds them in their configurations. Remove it simultaneously in all nuclei and you have triggered a nuclear event with no precedent in the history of the universe. Everything alive would cease to exist, not as frozen life, but as no longer life at all. Life is a process. Stop the process, and you have not preserved the distinction between the organism and its environment, time would become undefined. Not stopped and defined, because time as a physical concept requires change, ordering, sequence. In a universe with no events, the word when has no answer, and the second law of thermodynamics would ensure that a stopped universe, a minimum entropy universe, would be the most explosive possible initial condition for a resumption of motion. The universe would not stay still. It would resume more violently than it began. All of this tells us the same thing from different angles. Motion is not a property that matter has. It is a property that matter is, quantum mechanically, thermodynamically, relativistically. At every scale and in every framework we have, the universe is not a place where things happen to move. It is a place where things are motion, organized into patterns, some of which are stable enough to be called objects, living things, planets, stars, and you. You are not a still thing with motion added. You are organized motion, complex enough to be conscious, temporary enough to be precious, and built from the same restless quantum uncertainty that prevents the universe from ever going quiet. The question was, what would happen if everything stopped? The answer is that you cannot ask the question from inside the answer, because the you that is asking the question, the thought, the electrochemical signal traveling through your neurons right now, is itself a form of motion. Stop everything, and the question stops too. And somewhere in that fact, in the impossibility of asking the question from inside the answer, is the deepest thing physics has to say about what motion is. It is not the universe moving. It is the universe being, and the universe, as far as every law we have ever written can determine, has never, not for a single instant, stopped being. Everything is moving, you are moving. This thought is moving through you right now at roughly 100 meters per second as an electrochemical cascade from neuron to neuron. The screen delivering this to you is moving at 1,000 miles on a spinning planet falling around a star. The electrons encoding the signal are vibrating at frequencies your body cannot detect, but your atoms know perfectly well. And underneath all of it, in the quantum from which every particle you are made was briefly borrowed, there is a motion that predates the universe, as we know it, and will outlast every structure within it. The stillness you feel right now is not the absence of motion. It is the presence of so much motion, so finely organized, that the net effect at the scale of your body is the sensation of rest. Rest is not the bottom of the universe. It is one of its most sophisticated achievements, a temporary, local, carefully balanced illusion produced by the most relentlessly dynamic system that has ever been observed. If you enjoyed this, subscribe, because the questions only get deeper from here. And we are just getting started.